Hi, this is a short demonstration on the flexwing trim gauge that Cubyte Avionics has designed. It's basically a same type of style as the P&M original one, what you may find in your flexwing currently. We've had quite a few people not fully understanding how these devices work or where the bar position is, and they get really scared about it. Totally understand that. So hopefully in this video I can actually demystify how these devices work and how you set them up, and basically not to be scared of them. So on our gauge, and same as on P&Ms, you'll see that there's 3 wires. You've got a supply rail goes directly back to your 12-volt battery, obviously via a fuse or some sort of protection circuit, a ground reference, and then the blue wire, which is the signal wire. Now that signal wire runs all the way to the back of the aircraft, and you'll see a similar device to this one, which is a 10-turn potentiometer, and as you can guess, you can turn it 10 times. On your aircraft it very rarely moves more than a couple of turns round. I don't think it uses the full position, you know, it never does full 10 turns. I think the typical value is 100k. That's not so critical. The most critical part of this 10 turn part is the fact that it's 10 turns and it's linear. Never ever be tempted to replace this part with something that's logarithmic. Changing its value from 100k to 20k to 50k will not affect this operation of this one iota. It makes no difference. How these devices work is, obviously you've got your supply directly across your terminals here, and when you turn it, this wiper moves up or down this variable resistor effectively, and the closer it gets to this side, the higher to 12 volts it's going to be, and as it moves down this way, the closer to 0 volts it's going to be. And that's it. That's how this device works. So as you alter your trim, it's just moving this position on this wiper, so you're just expecting the voltage coming back here. Now an aircraft that I've measured, it's typically around about 1 volt to 3.5 volts, 4 volts maximum. So you can probably say that if this were 10 turns and it were 10 volts, it's rotated 3 times effectively. So they're not moving the entire range area, and this is what people get confused with, because you can buy these simple displays off Amazon, and they're a voltage indicator, and they only have 2 wires, and they're trying to always read the battery voltage. So then they haven't got this spare input here, so they're never going to read right. So it is a special sort of design to get it to read a separate voltage. Now when this voltage comes in here, because we're only using between 1 and say 4 volts or 5 volts, we have to calibrate it so that this screen will show full deflection. So as I rotate the pot, I can get full deflection. Okay, so 8 volts I've got full scale down to 0 volts effectively. Now one thing you might have noticed, that this is in what we call bar graph display, which is showing all the LEDs lit. Typically they come in dot mode, and we ship them out in dot mode. If you want it in this configuration, just let us know and we'll make the modification to do this. It's just an extra wire on the back. It's not a big thing. I quite like it in this one, but the calibration is what most people get stuck with. So how we calibrate ours, and it's when I say calibrate, they're setting it to a known input voltage is going to display the same number of bars. It's not calibrating the wing position or anything else. This is only for reference. It's not an absolute value of the trim bar. So bearing that in mind, it is only a reference. It's not going to affect your flying. Your control bar is always how you fly the aircraft. So on back of our display, and same on P&Ms, you will see a little potentiometer. It's a smaller version than this. It's exactly the same, there's no difference, it's just physically smaller and at a slightly different value. If you could put a small screwdriver in here and turn it anti-clockwise, with the small voltage going in, it will actually show more indicated voltage. Turn it clockwise and again it will send it towards this position and turn off these LEDs, so it moves it down. So just to demonstrate that, I'm just going to put my screwdriver in back, and what I'm going to do is I'm going to turn it anti-clockwise at the moment, so it'll start to increase the display all the way up to full, and if I turn it clockwise it'll turn them down. And this is how you calibrate the display, so you can turn it fully off or up or down. So you can set it to the position where you normally fly. If you normally have it set to number 6 in neutral position, you can adjust it on that trim pot to do that. There's nothing complicated about these things. So if you like this device and you want one, drop us an email at Cubyte, cubyte.avionics@gmail.com, and we can supply you one. Or find us on Facebook or even on our YouTube channel. Coming soon is a new headset that we've been working on, and hopefully what we're going to do is have a look at tear down the other avionic equipment and see how you can repair them, where to get the parts from, and basically see if we can get more of your pilots repairing your own stuff. Catch you later.